Hello and welcome. We are looking at proving lines parallel. And this video is going to be just a little bit different than some of my other videos because these slides will contain pretty big walls of text. And as I go through it, I might be speaking a little more quickly than you have time to read or comprehend it. So please feel free to pause as you need to and rewind and whatever else because not too much math will be going on in this one. Okay, first thing that I want to state is the next set of slides will have these two statements showing up every single time. All angle property theorems and postulates are biconditional, which means their converses are also true. There is a one-to-one correspondence between the if-then portions of each statement. What that means is we've been looking at statements involving angle pair relationships, such as corresponding angles, alternate interior-exterior angles, and same-side interior-exterior angles. And when we have parallel lines in a transversal drawn through those two parallel lines, then corresponding angles, alternate interior angles, and alternate exterior angles all became congruent, and same-side interior angles and same-side exterior angles became supplementary. That was only true for parallel lines. Now the converse would state if we knew we had congruent alternate interior angles, alternate exterior angles, corresponding angles, or if we knew we had supplementary same-side interior angles, same-side exterior angles, then it's true that we have parallel lines. So we're going to be talking about that a little bit. Don't worry, we'll get into that statement, but I just want you to know what biconditional means. Basically, if I switch the if to the then and the then to the if, and both are true in either case, then that makes them biconditional. So we'll look at a biconditional case in a real-world scenario, and then some non-biconditional cases, and then we'll tie it into math, and then we'll tie it into the things we've been talking about. Okay, so true statement whose converse is true. So here's a statement. If dishes are washed, then they will be clean. Yeah, assume that's true and how it is. And if I have clean dishes, then they were washed. Which is, I guess that's also true unless you buy them from the store, in which case I hope they were also kind of washed, but you know what I mean. Those are both true. A true statement whose converse is false. So a true statement, if a car is out of gas, then it won't run. It's true. But now you switch that. If a car won't run, does that mean it's out of gas? It could, but it's not always true. It could be the battery's dead. It could be a lot of different reasons. It could be missing tires. A false statement whose converse is true. So basically what I do is I look at something that would be true as the converse and make that the original. So if I went to see a movie, then I paid for a movie ticket. Not necessarily. Someone else could have paid for you as you went together. You could have snuck in. Anyway, so it's false. If I paid for a movie ticket, then I went to see a movie. Okay, yeah, that's true. And that's assuming you're not like the parent who's dropping off their child at the theater and saying, have fun, here's some money. What I mean is you go in the theater, you're paying for that ticket. You're not just giving it to some random person. You are going to see that movie. And then a false statement whose converse is false. If I was involved in a car accident, then I suffered injuries. False. You could have had a little car accident. You could be walking away just fine from there. If I suffered injuries, then I was involved in a car accident. Also not necessarily true, right? I could have banged my knee on a table. I suffer an injury there. Doesn't mean I have to be in a car accident. So the only biconditional one is the first one, this particular case. So by one-to-one, it means that there's nothing which doesn't make it false when I switch it. So here's some mathematical conditional statements where I can have, well, we're going to go through these examples together as well. Here's a true statement whose converse is true. If an angle measures to 90 degrees, then it's a right angle. That's true. Converse, if an angle is a right angle, then it measures to 90 degrees. Also true. So those are biconditional mathematical statements. True statement whose converse is false. If two lines are skew, then they are not parallel. That's true. They cannot possibly be parallel if they are skew. There's no possible way. If two lines are not parallel, then they are skew. That's false. Here's an example of two lines that are not parallel and not skew. They're intersecting. Remember what skew lines are. They are lines that are non-coplanar. And that was not mentioned on here at all. Here's something about coplanar. A false statement whose converse is true. If 4 points are coplanar, then they are also collinear. False. Here are 4 points on a plane, on the computer screen plane, and they are not collinear. Right? But if 4 points are collinear, then they're also coplanar. That is true. If they are on the same line, then that line is on some plane or some multiple planes. They are all on any same plane together. And a false statement whose converse is false. If two non-zero numbers are multiplied, then the product becomes 0. There's something called the zero product property, which says one of your values must be 0 in order for you to get a product of 0. So that's false. And if the product of two numbers is 0, then both are non-zero numbers. Once again, that's false. If you get if you get an answer that's 0, that was two numbers being multiplied, one of them had to have been 0. They can't both be non-zero. So again, the only biconditional statement is the one whose converse was true. So now I want to segue this into the angle properties that we've been referring to so far. Now all of these are biconditional, so it's true for both sets of statements for all of these. Now the top statements are the ones that you learned in perhaps the last video if you heard it. If a transversal intersects two parallel lines, notice how that's the same each time, then we're referring to things such as corresponding angles, alternate interior angles, alternate exterior angles being congruent. That is true. And same side interior angles and same side exterior angles are supplementary when you have the two parallel lines. Now their converses are also true, meaning if I switch the then to the if and the if to the then, if two lines and a transversal form and corresponding angles, alternate interior angles, or alternate exterior angles are congruent, then those two lines are parallel. So you can look at it the other way and say for sure that you know that that will be the case. Same with same side interior angles and same side exterior angles being supplementary. If that's true, then your lines are also parallel. So that's all this section is. It's just the opposite form of what you have. And then just a bottom footnote here, vertical angles and adjacent angles neither need nor use anything to determine whether lines are parallel. So in other words, if I know that vertical angles are congruent, which is always true, that says nothing about this line and this line being parallel, right? I can't make a statement saying that. Or if I say these two angles are supplementary, that says nothing about these two lines being parallel. So you can't use justification for that, but they can be used to help aid the above angle relationships to find parallel lines and to find angle measures and stuff too. My very last example will cover that, perhaps. Okay, so now I have an example here. Using the diagram and given information, we're going to find angles based on the relationship and angle given, and assume angles which appear congruent are congruent, meaning 19 is congruent to 37 and 55, etc. So you have lines right there. What we're going to do is look at each of these sets. Now I know this is a massive figure, but we're going to look at each of these sets here. We want to look at angle 10 right here and see what angles correspond with it. Okay, we're going to see what angles correspond with, meaning what corresponding angles there are, and we're going to assume that any other ones that correspond are congruent. And whenever we say that, then we can say which other lines are parallel. So the way to form the angle is to look at the two lines that form it. Okay, now if I'm going to look at corresponding angles, all of my corresponding angles will have to be on this line E or this line A. They have to be. And then whatever angles form, so for instance, if I take a look at this one here, angle 12 with angle 10, that one's also on line A, and angle 12 is also formed with line F. Now A ends up being the transversal with these two lines E and F drawn. And because corresponding angles are congruent, then these two lines, the ones matching color in green, are parallel. E and F are parallel. Now those aren't the only corresponding angles with 10. 10 and 14 also correspond. We can jump line F and go to line G. 10 and 14 are congruent. A is the transversal, so E and G are parallel. Also, angle 16, 10 and 16 are congruent, E and H are parallel. But those aren't the only ones, right? We can also use E as a transversal and have corresponding angles with 10 and, say, 26. If E is the transversal, 10 and 26 are corresponding angles that are congruent. If that's the case, lines A and B are parallel. 10 also corresponds with 42, so lines A and C are parallel if they're congruent. And 10 also corresponds with 58. Lines A and D are parallel. Now 10 can't correspond with, say, 46, right? These aren't corresponding angles. In order to have corresponding angles, you need two lines such as A and C, but you need one transversal. Now, there's a transversal there and a transversal there, but you need one of them to be referring to corresponding angles. So that's not the case for this. These are the ones that correspond with 10, and those lines that I spoke of were the parallel ones. Now let's look at alternate interior angles with 45 right here. So alternate interior meaning on the opposite side of a transversal. So I can either use a line G or C as the transversal. I'll go ahead and do G first. And it needs to be on the inside path. So say 45 is on the inside here, 54 is on the inside here. So these are the only two alternate interior angles with G as a transversal. And if these two are congruent, as they are assumed to be, then C and D are parallel. Okay, so there's that one. Now, like I said, that's the only one on this transversal G. 30 is not an alternate interior angle with 45. 45 is on the outside of lines B and C. Okay, but I can use C as a transversal, and if I have 45 here, here's an alternate interior angle, 36. 45 and 36 are congruent, so lines F and G are parallel. Here's another one if I pass line F and go to line E. Alternate interior angles, 45 and 34, so G and E are parallel if they're congruent. And again, C is the transversal. Now those are the only ones. There are no other ones that I can make alternate interior angles with because this is the only transversal I can use, or G was the only transversal. Alternate exterior angles with 60, here's angle 60. Alternate exterior angles will be angles where are opposite a transversal, let's say F or D, and then they are on the outside of your lines that you're matching up with. So first I'm going to make D a transversal, and as I do, the only alternate exterior angle I can make here with 60 is 49. They are on the outside of the lines that are made going through the transversal, and they will, if they're congruent, then E and F are parallel. Now, that's the only one there, so now I'm going to make F my transversal, and you can see 60 and 35 are alternate exterior angles, and if they are congruent, C and D are parallel. 60 and 19 can be alternate exterior angles. If that's the case, B and D are parallel, if these are congruent. And 60 and 3. As you can kind of see how it goes up, don't let this big diagram fool you into thinking that it's hard to find out what you need. Try and hide everything else. Now, I know you can't color code and bold and do the things that I'm doing here, but these still are cases of that. All you need to find is what the where your angles are and what line is shared with both of them. In this case, F is, that's the transversal. And then what other line is used to make the angles, in those cases D and A. And if they're congruent, then D and A will be parallel. Now let's go same side interior angles with angle 39. So this time I'm going to use a transversal that's on the same side, where my angle's on the same side of the transversal. So let's say I use H as a transversal. Well, then if I use angle 31, this is the same side interior angle with 39. Now 31 and 39 aren't congruent. Make sure you understand that. They're supplementary though. So if you assume that some angles are congruent, then you have to assume the others are supplementary. If 39 and 31 are supplementary, then B and C are parallel. That's not the only same side interior angle. There's also 15. 39 and 15 are supplementary, so A and C are parallel. Okay. Again, I'm going with my earlier statements that I talked about. These are the converses of if we knew A and C were parallel, then same side interior angles would be supplementary. Well, the converse is also true. If same side interior angles are supplementary, then the lines are parallel. But that's all I can fit for same side interior angles on this transversal. Now let's make C the next transversal with H. If C is the transversal, here are same side interior angles, 39 and 38. If supplementary, G and H are parallel. 36, make F and H parallel. And 34, make E and H parallel. And hopefully you're getting the gist. I'm obviously saying the same thing over and over, but I want to make sure that you can always run through every single instance of what's happening, and you can see them all. And the last one, same side exterior angles with angle 4 right here. So same side, literally meaning it's got to be on this side somewhere. And exterior, if this one's going to be on the outside somewhere, then I have to look on the outside over here, which means that I can draw a transversal on A, and then angle 1 can be the same side exterior angle with angle 4 on that transversal. If these are supplementary, then lines E and F are parallel. No, that's the only same side exterior angle I can make on A as the transversal. What if I make F the transversal? Well, angle 28 can be a same-side exterior angle that make lines A and B parallel. 44 and 4 are supplementary, then A and C are parallel. And angle 60 can be a same-side exterior angle with 4, where if they are supplementary, then A and D are parallel. So that's it, and that's all, folks. Now, what if I had an example here where we assume that these lines are now parallel, A, B, C, and D, and E, F, G, and H are parallel, and we need to find some angle measures. Well, now it's kind of important to say, well, if these are parallel, then certain things are congruent. For instance, where can I build up here? I could do something that sets 2x equal to x plus 4y because those are vertical angles, but that doesn't help me solve for a variable because I have 2 unknowns and only one equation. So that's not going to help. What I need to do is find 2 sets of matching variables where I can make an equation true. Like these two guys right here, 3w plus 20 and 84 minus w. Now both of those are alternate interior angles. The transversal is line E, and lines A and B are the parallel lines. Right? They are parallel. If that's true, alternate interior angles are congruent. So 3w plus 20 equals 84 minus w. And if you use algebra, I'm going to add w to both sides, and I'm going to subtract 20 from both sides. And then divide both sides by 4. That's the division property of equality. And you get w equals 16. So I solved for one of my variables. What can I do from there? I can now substitute in 16 for w for any of these, and I should get the same angle for either. I'll just do it here. 84 minus 16, that's 68. So this becomes 68 degrees, and I could either substitute 16 in here, but I could just as easily say this is also 68. So how will that matter? I could go one of two ways now. I could refer to this angle 68, and all the way over here, this angle 2x is a same side interior angle with 68. Why? Because if B is a transversal, then E and H are the parallel lines, then here are your same side interior angles. And those are supplementary, which means if I add 68 with 2x, I'm going to get 180. If I subtract 68, I'm going to get 2x equals 112. And if I divide by 2, I'm going to get x equals 56. So that's a way to solve for x. Okay. Solving for y is going to now help by using these vertical angles. Remember before where we said 2x is equal to x plus 4y? Well, now I know that x is 56. Now I only have one unknown. 2 times 56 is 112. You can already see that right here. So 112 is 56 plus 4y. Subtract 56 and you're back to 56 again. 56 equals 4y. Probably should have subtracted x from the beginning. Divide by 4, you're going to get y equals 14. So, how much is this angle measure? That's 112. That's 180 minus 68. So this is also 112. I could double check by substituting 14 for y and 56 for x, but let's trust it for now. Vertical angles are congruent. Remember what I said before? Vertical angles will help us in the cases that we're referring to these other angle relationships. Here's one of those instances where it helps you use things with parallel lines, but it doesn't help you say lines are parallel. I hope that makes sense. Now I have to solve for z, and there are two different ways I can solve for z. I found out that this was 68 a long time ago, and here I have this angle way down here that's z minus 2. So here, these two angles, 68 and z minus 2, on E as the transversal, A and D are parallel. These are both corresponding angles, and those are both congruent. So one way I could solve for this is by setting 68 equal to z minus 2. If I add 2 to both sides, I'm going to get z equals 70. That's a pretty quick way of finding it out. The other way is by seeing this set of corresponding angles right here with B and H intersecting, and then with H and D intersecting. As you can tell, H is the transversal, and B and H are the B and D are the parallel lines. So these corresponding angles are congruent. So I could set 112 equal to x minus the quantity y minus z. So let's say we don't know what z is yet, right? Because I found this out another way. I want to show you the second way. I subtract 56 from both sides. I'm going to get 56 equals, if I distribute this negative into here and here, I'm going to get negative 14 plus z. If you add 14 to both sides, you're going to get z equals 70. So either way, you solve for z there. And then find the two unique angles formed here. Everywhere you're going to see a bunch of 68s. Anything that looks acute is 68. The rest that look obtuse are all 112. And that's it, and that's all. Fiend.